So imagine if tomorrow, hiring a senior software engineer, a lead UI designer, and like a seasoned video editor suddenly cost you exactly $0.
Which is pretty hard to imagine, honestly.
Right, and imagine it took exactly 3 seconds to onboard them. And, imagine if that team didn't need sleep, they didn't ask for equity, and they could instantly read and comprehend every single piece of documentation your company has ever produced.
Literally in the time it takes you to sip your coffee.
Exactly. We aren't talking about some hypothetical scenario 5 years from now. We are talking about what is happening on screens all over the world, like today.
Yeah, right now.
So welcome to the deep dive. Today is July 9th, 2026. And for you listening, we know you want to stay ahead of this technology curve.
We have to.
Right. You want to understand the tectonic shifts in how work actually gets done. But, you also have a day job, and you absolutely do not want to drown in technical white papers.
Oh, definitely not.
Or spend your entire weekend parsing dense API documentation just to figure out, what tool to use on Monday morning.
Exactly. I mean, the pace of information right now is just punishing. You need the signal through the noise, right? The practical reality of what these tools can actually do when all that marketing hype fades away.
Okay, so let's unpack this, because today we are looking at an absolute mammoth of a topic.
Huge.
It's OpenAI's official general availability launch of the GPT 5.6 model family.
A very big deal.
It really is. And to figure out what this actually means for you, we have a fascinating stack of sources to guide us. So we're looking at the official OpenAI release announcements and the technical specifications, of course.
Which are dense, to say the least.
Very dense. But we are crossing those official specs with 2 rigorous real-world stress tests from prominent technology reviewers. And what's cool is they approach AI from completely opposite directions.
Yeah, that contrast is super important here.
First, we have data from World of AI. And this is a source that goes incredibly deep into raw benchmark scores, algorithmic coding performance, and some absolutely mind-bending procedural generation.
And to balance that out, because it's a highly technical quantitative approach, we are pulling from a reviewer known as How I AI.
Right.
Her name is Claire, and she is a working product manager. She runs what she calls a highly scientific vibe review.
I love that, a vibe review.
Yeah, it's great. She doesn't care about theoretical benchmark percentiles. She focuses on the practical, everyday reality of product workflows, user interface design, and really just how these models actually feel to collaborate with when you're under a deadline.
So the mission for this deep dive is pretty ambitious. We are going to figure out if GPT 5.6, specifically the flagship model they named Sol, is actually the highly anticipated killer to its main rival, Claude Fable 5.
It's a big showdown.
Exactly. We want to know how these models translate from abstract, sterile lab environments into actually getting your everyday work done faster, cheaper, and, with significantly less headache.
Which is what everyone actually cares about.
Right. And to start, we really need to look at the new roster and what I'm calling the economics of intelligence. Because OpenAI didn't just drop one model, they gave us a highly stratified family of 3.
Right, it's a very deliberate segmentation on their part. You have Sol, which is the flagship model built for complex, long-horizon agentic work.
The heavy lifter.
Exactly. Then you have Terra, which is the balanced mid-tier model. It's designed for everyday professional workloads where you just don't need maximum compute.
Makes sense.
And finally, Luna, which is the hyper-fast, highly affordable model designed for high-volume, repetitive tasks.
But, the striking part to me isn't just that they segmented the models. I mean, we've seen small, medium, and large before.
Sure, yeah.
It's the pricing economics that really feel like a line in the sand. According to our sources, specifically the breakdown from Claire's review, Sol is priced at $5 per $1 million input tokens and $30 per $1 million output tokens.
Which is wild.
It's insane. To put that in stark perspective for you listening, Sol is exactly half the cost of its main competitor right now, Claude Fable 5, which is sitting at $10 for input and $50 for output. OpenAI is basically declaring a price war on frontier intelligence.
They absolutely are. But the base price is actually the least interesting part of the economic shift here.
Really? How so?
Well, what fundamentally alters the landscape are the new caching mechanics they introduced alongside these models.
Okay, let's pause here for a second, because caching is one of those terms that gets thrown around a lot.
Oh, constantly.
Yeah. My basic understanding is that caching is like short-term memory.
Right. That's a really good way to look at it.
So instead of the AI having to reread a massive document every single time I ask it a follow-up question, it holds that document in its active memory for a bit. Is that roughly what we're talking about?
That's a perfect analogy. Think of the context window, the amount of text you can feed the AI, like a giant whiteboard.
Okay, a giant whiteboard.
In older systems, every time you asked a new question, you were paying the AI to meticulously copy everything from your hard drive onto that whiteboard, read it, answer your question, and then immediately wipe the whiteboard clean.
Oh, wow. So you just lose it all instantly.
Exactly. So if you asked a second question 5 seconds later, you paid to have the entire whiteboard filled out again from scratch. It was wildly inefficient.
Which is why developers were constantly trying to minimize how much context they sent.
Precisely.
Like, if you're building an app that automatically reviews code, you couldn't afford to send your entire company's code base to the AI for every single bug fix. It would literally bankrupt you.
Yeah, you'd burn through your budget in a day. But with this 5.6 release, OpenAI is guaranteeing a 30-minute minimum cache life.
30 minutes. Okay.
Now, to write that information to the cache initially, it costs 1.25 times the normal input rate. So you pay a slight premium up front to get it on the whiteboard.
Right, a little extra to start.
But here is the massive shift. Once it's there, any subsequent reads from that cache get a 90% discount.
A 90% discount. That's basically free.
It changes everything.
So if I have an AI agent that is looping, say it's looking at a bug, writing a fix, testing it, reading the error message, and then trying again, I'm not paying full price every time it loops back to look at the original code.
Exactly.
Yeah.
This is why caching matters just as much as raw intelligence. It makes complex, repetitive, iterative tasks economically viable. It shifts the entire engineering paradigm.
How so?
Well, last year the goal was, how do we engineer the perfect prompt so the AI guesses the right answer on the very first try? Because the second try was just too expensive.
You had to get it right immediately.
Right. But now the paradigm is we can afford to let the AI check its own work 50 times until it's flawless.
Wow. Let me try to map this to a real-world scenario so I can wrap my head around it. I'm looking at these three models, Sol, Terra, and Luna, and with these new economics, it feels like building a corporate team. Sol is your brilliant lead architect. You bring Sol in for the toughest, most ambiguous problems. Terra is your reliable mid-level manager who writes the standard reports and keeps the lights on. And Luna is the hyper-caffeinated intern.
The intern. I like that.
Right. You give Luna mountains of messy data to sort through, rapid-fire tasks that just need to be categorized instantly.
And you don't pay the lead architect's hourly rate to sort them in, right?
You delegate.
Exactly. But I want to push back on the existence of Luna for a second here.
Sure.
Because Luna is priced at $1 per million input tokens and $6 for output. That is practically free.
It is remarkably cheap.
So I look at that and wonder, is this just a race to the bottom? Is OpenAI just putting out a cheap, degraded model to undercut open source alternatives? Or is there a genuine architectural need for smaller, cheaper intelligence in a world where Sol exists? I mean, if I can afford Sol, why would I ever use Luna? That is a fundamental question about where AI is heading right now. And it is absolutely not just a race to the bottom. There is a profound architectural need for small models, and it all comes down to routing.
Routing.
Yeah. As we move away from chatting with a single AI and move toward multi-agent systems where you have dozens of AI models talking to each other behind the scenes to complete a task, you realize that most steps in a workflow don't actually require deep reasoning.
Give me an example of that.
Let's say you build a workflow to analyze a competitor's market strategy. You definitely need Sol for the final step, synthesizing the data and writing the strategic analysis. That requires high-level reasoning.
Right, for the hard part.
But the first step, scraping 10,000 web pages, identifying which ones are press releases, extracting the dates, and filtering out the 404 error pages.
Oh, I see.
If you use Sol for that, you are wasting massive amounts of compute and money. You need Luna to act as a high-speed filter. Luna processes the raw chaos, formats it cleanly, and hands it up the chain to Terra or Sol.
So it's basically doing all the grunt work.
Exactly. Without a highly capable, ultra-cheap model like Luna acting as the nervous system, complex agentic workflows just become economically impossible to scale.
So Luna isn't the brain. It's the nervous system routing the signals.
That's a great way to put it.
That makes complete sense. So the economics are aggressive, the routing architecture is there. But, cheap compute and smart routing are totally useless if the flagship model is hallucinating its way through your code base.
Very true.
So let's talk about the raw power of Sol. This brings us to a battle of brute force versus elegance. I want to look at the benchmark data from the World of AI source.
Ah, the sterile ad results. This is where we see what the engine can do when pushed to the absolute red line.
Right. And to push it to the red line, OpenAI introduced two new reasoning parameters, max and ultra.
Yeah.
Now, the max setting is fairly straightforward. It gives the model more compute time to reason, explore alternatives, and self-correct before it spits out an answer.
Basically telling it to think longer.
Yeah. But ultra is wild. According to the documentation, when you engage Ultra mode, the system defaults to coordinating 4 separate agents in parallel to synthesize complex tasks.
Which ties perfectly back into our conversation about caching, if you think about it.
Oh, how so?
You can only afford to have 4 agents working in parallel, reading the same source material simultaneously if that 90% caching discount is applied. The economics unlock the architecture.
Oh, wow. I didn't even put that together. And the architecture clearly unlocks the performance.
Definitely.
Let's look at these World of AI benchmark results. The reviewer ran Sol through exam PBC 5.6.
Yeah.
And for context for you listening, PBC stands for Planning and Basic Control. It's this really rigorous benchmark that tests how well an AI can plan out a multi-step task and control digital environments.
It's a tough one.
It really is. So Sol hit 53.6%. That beats Claude Fable 5 Adaptive by 13.1 points.
Wow.
In the world of frontier AI benchmarks, a 13-point lead isn't just a win, it's a blowout.
It is a massive margin. It indicates a step change in spatial and temporal planning.
And it gets even more intense. Using that Ultra mode on Terminal Bench 2.1, Sol hit 91.9%, surpassing Claude Mythos 5's score of 88%.
That's huge.
Now, Terminal Bench tests how well an AI can autonomously operate within a command line interface, basically acting as a systems administrator.
Hitting nearly 92% on Terminal Bench implies a level of autonomy that is deeply impressive.
Yeah.
I mean, it means the model isn't just guessing commands, it's reading the system state, understanding the errors, and navigating a file system almost flawlessly.
It also scored an 80 on the Artificial Analysis Coding Agent Index, putting it nearly 3 points ahead of Fable 5. But here's the part that really caught my eye.
What's that?
The reviewer noted that Sol is achieving these state-of-the-art results while using less than half the output tokens, completing tasks in less than half the time, and costing roughly 1/3 less than Fable 5.
That's efficiency right there.
Right. It's not just smarter, it's exponentially more efficient.
What's fascinating here is the underlying mechanics of that Ultra mode. We are witnessing a fundamental shift from single-thread generation to default multi-agent orchestration.
Okay, unpack that for me.
When you select Ultra, you are no longer just prompting a single neural network to predict the next word in a sequence. You are effectively spinning up a microscopic development team.
A microscopic team.
Yeah. Having 4 agents work in parallel means the system is brainstorming, drafting, fact-checking, and iterating on its own work in the latent space before it ever shows you a result.
Okay, I have to jump in here and push back on this Ultra mode concept.
Go for it.
Because I'm looking at this 4-agent parallel architecture, and honestly, it feels a bit like cheating. It feels like brute force.
Interesting. Why cheating?
Well, if I have a complex math problem and I give it to 4 average mathematicians instead of 1 absolute genius, the 4 average guys might get the right answer by checking each other's work and voting on the outcome. But it doesn't mean the core intelligence of any individual mathematician has actually improved. So are we actually making the core neural network smarter, or are we just papering over its weaknesses by throwing massive amounts of compute at the problem?
That is the ultimate debate right now in artificial intelligence. Are we approaching the ceiling of raw neural network intelligence and therefore pivoting to scaffolding and orchestration to squeeze out better results?
Exactly.
You are right to call it brute force. It is brute forcing reliability. But this raises an important question for you, the user. Do you actually care how the intelligence is generated, as long as the code works perfectly on the first try?
Probably not. I mean, if my app compiles and ships, I don't care if 1 digital genius wrote it or 4 digital average guys cross-checked it.
Precisely. In enterprise software, reliability and predictability are vastly more valuable than pure, unbridled genius that occasionally hallucinates and deletes a production database.
Fair point.
But to defend the architecture a bit, coordinating 4 agents effectively is not a trivial task. It requires a massive amount of meta-intelligence.
How so?
Well, the orchestrating model has to know how to break down your prompt, delegate the subtasks to the parallel agents, evaluate conflicting outputs from its own subagents, and synthesize a cohesive final product.
Oh, I see.
That routing and synthesis capability is a profound form of intelligence. It's the intelligence of a manager rather than an individual contributor. So yes, it's brute force compute, but it is highly orchestrated, highly semantic brute force.
That's a really great distinction. The intelligence is in the management and the synthesis.
Exactly.
But as impressive as a 92% on-terminal bench is, benchmarks are played in sterile lab environments. They are highly controlled.
Very controlled.
So how does this AI behave when a human being with changing requirements, messy data, and tight deadlines is actually trying to build a product with it? This transitions us perfectly from the sterile lab to the messy real world and what I am calling the pedantic trap.
Ah, yes. Let's dive into Claire's review from How I.
Yeah, let's do it.
This is where we measure the gap between theoretical intelligence and practical effectiveness.
Yeah.
Because, a model can be brilliant in a benchmark, but utterly useless in a workflow.
Exactly. So Claire created a qualitative benchmark heavily weighted on things product managers actually do every day.
Like what?
Like front-end prototyping, writing product requirements, documents, or PRDs, and complex debugging. And her contrast of the working styles, like the literal personalities between GPT 5.6 Akal and Claude Fable 5, is incredibly revealing.
She painted a very distinct picture of their operational styles, didn't she?
She really did. She described Claude Fable 5 as acting like an alien engineer.
An alien engineer, wow.
Yeah, she said it is hyper-technical, it is stubbornly pedantic, and its communication style is inscrutable. She said it writes code and explanations in a way that is for agents, by agents, making it incredibly frustrating for a human to collaborate with.
That sounds awful.
It's like working with the most brilliant back-end developer in your company, but they completely refuse to speak plain English.
Right. The classic brilliant jerk archetype, but rendered in silicon.
Yes, perfect way to put it. And she gave a specific example that absolutely blew my mind.
What was it?
So she was building an integrated prototyping tool inside an application called Chat PRD.
Okay.
Fable did a lot of the heavy technical lifting up front, setting up the complex architecture, but then it got so obsessed with security, deterministic outcomes, and theoretical perfection that it built this incredibly hardened, rigid tool calling loop.
Uh-oh.
It hardened the architecture so much that it actually broke its own tool.
It locked itself out of its own house.
Exactly. She could not get any other AI model to run inside the prototyping tool because Fable had locked the permissions and the input expectations down so tightly.
That is so frustrating.
And when she tried to troubleshoot it with Fable, Fable essentially blamed the other models, refusing to acknowledge that its architecture was too rigid for practical use. Fable got completely bogged down in linting.
Ah, linting. Which, for anyone listening who might not code every day, linting is essentially the automated spell check and grammar police for code logic.
Right.
It checks for stylistic errors, potential bugs, and strict adherence to formatting rules. It's necessary, but it can be overwhelmingly pedantic.
Exactly. Fable cared more about the code passing the linting test than it cared about the tool actually functioning for the user. So she switches over to Sol. She feeds Sol the broken architecture and basically tells it, look, stop being pedantic, loosen the constraints, just get this thing working.
And how did Sol respond to that kind of heuristic, ambiguous instruction? Because models usually hate that.
Sol immediately backed off the rigid constraints, identified the bottleneck, and fixed the loop in one shot.
Wow.
It understood the assignment wasn't write perfect code. The assignment was make this tool work.
That's a huge difference.
And she had another project, too. It was this Insights Ingest product, where she was trying to pull unstructured data from Intercom customer tickets, linear project management boards, and GitHub commits to build a synthesized product wiki.
That sounds incredibly messy.
Super messy data. Fable got completely paralyzed trying to ensure every single piece of generated prose was perfectly reproducible and citation-backed. It just stalled out.
It couldn't handle the mess.
Right. Sulla, on the other hand, abandoned the pedantry, accepted the messiness of the data, and successfully generated highly useful, synthesized wiki pages.
If we connect this to the bigger picture of software development, what Claire's describing is the fundamental tension between deterministic environments and heuristic environments.
Break that down for me. Why is one model so rigid and the other so flexible?
Well, it comes down to what the models are optimized for. In certain domains, like cybersecurity, which Fable is historically exceptional at, you need a deterministic machine.
Because the stakes are higher.
Exactly. There is no room for vibes or loosened constraints when you are patching a zero-day vulnerability in a bank server. It is deterministic. It either is mathematically secure or it isn't.
Right.
So Fable's pedantic, hyper-technical, hardened approach is a massive asset in that specific domain. But consumer software, product design, and prototyping, that is heuristic.
Meaning it's more about the feel.
Yeah, it's about intuition, messy user data, edge cases, and finding good enough solutions that ship on time. Strict rigidity breaks the user experience.
That makes total sense.
Sol's ability to seamlessly shift gears to understand the context of the prompt and realize, she wants a working prototype, not a cryptographically secure vault,
Yeah.
represents a massive leap in practical collaborative AI.
I really like that framing. It perfectly captures how I felt reading her review. Let me try an analogy here.
Go for it.
Fable is the brilliant back-end engineer who refuses to ship the update because the code isn't theoretically perfect. Like, it could be 1% more efficient, the formatting could be cleaner, so they hold up the entire release cycle for a week.
We all know that engineer.
We do. But Sol is this scrappy hacker who duct tapes the back-end together, uses a couple of slightly messy workarounds that wouldn't pass a computer science exam, but the app actually works, it feels great to the user, and most importantly, it ships on Friday.
And in the business world, the product that ships on Friday usually beats the perfect product that ships 6 months later.
Every single time. So, if Sol is the scrappy hacker on the back end who actually ships the product, how does it perform when it has to put on a UI designer's hat? Because, a fully functional backend doesn't mean much if the user interface looks like a confusing spreadsheet from 1995.
Very true.
So let's look at front-end generation, aesthetics, and what Claire hilariously dubbed woodland elegance.
This is a critical evaluation point, because historically, OpenAI models have been incredibly strong at back-end logic and Python scripts, but they have really struggled with the nuances of front-end aesthetics compared to competitors like Claude or Midjourney.
Well, the sources suggest they have closed that gap significantly.
Well, yeah.
Yeah, let's go back to the world of AI coding tests. The reviewer gave Sol a monumental task: generate a functional macOS clone that runs in a web browser.
A whole OS clone.
Yes. And to be clear, we are not talking about generating a static JPEG that looks like a desktop. We are talking about functional code.
Right, so HTML, CSS, and JavaScript working in tandem to create an interactive state.
Exactly. And the result was a web app with a fully functional top menu bar. You could click on the Launchpad icon and the application grid would open smoothly. You could use a working Spotlight search feature to find things within the simulated OS.
That is wild. That requires incredibly complex state management. The AI has to understand the document object model, the invisible skeleton of the web page, and write logic that says, when this pixel is clicked, hide these elements, reveal these elements, and animate the transition.
And it gets wilder. Inside this clone, Sol generated an interactive music app, an activity monitor that simulated system resources, a paint application, and it even embedded a multi-wave FPS shooter game directly onto the desktop.
It built a game inside the clone.
Yes. Furthermore, the settings menu actually worked. If you changed the accent color in the settings app, it dynamically updated the UI across all the other simulated applications.
To generate that level of interlocking functionality from a single prompt, or even like a short iterative loop, it's just a testament to how well Sol handles complex spatial and functional relationships.
It really is.
It isn't just writing isolated scripts, it's holding the entire architecture of the application in its context window and updating it holistically.
But the clone that really caught my attention was the Minecraft clone.
Okay.
The reviewer had Sol build a browser-based Minecraft clone using Three.js. And just to clarify for anyone who hasn't spent their weekend reading graphics documentation, Three.js is a very complex JavaScript library used to render 3D graphics in a standard web browser.
Not easy to use at all.
Right. And the prompt wasn't just make a block game. Sol coded in specific break animations for the blocks, unique sound effects depending on what material was being mined, a functional inventory system, a health and hunger bar, and distinct creative and survival modes.
That's incredible because generating 3D logic via text prediction is notoriously difficult. The model has to translate language into vector math.
And it did it flawlessly. But here is the detail that shows true latent reasoning, in my opinion. Sol proactively coded proper water dynamics and, surprisingly, added mobile touch controls to the interface without being explicitly asked.
Wait, it just added them on its own?
Yes.
See, that is the fascinating detail right there. It proves the model isn't just regurgitating a how to build Minecraft and JavaScript tutorial it memorized from its training data. By adding mobile touch controls, it's anticipating the deployment environment.
Exactly.
It understands the context that a browser-based game in 2026 will likely be accessed on a tablet or a phone, And it proactively engineers the accessibility options. That is heuristic reasoning.
And what blew my mind is that this front-end capability isn't locked behind the expensive Sol
Oh,
model.
really?
The reviewer showed a highly qualitative, visually beautiful landing page generated by Terra, the mid-tier model, with its advanced thinking parameters completely disabled. And even Luna, the tiny $1 per million tokens model, generated a front end that the reviewer said was on par with Claude's best design capabilities.
Which brings us to the subjective realm of aesthetics.
Mhm.
Because, function is one thing, but form matters.
Yeah.
How did Claire rate the actual design taste of these models in her vibe check?
Oh, this was my absolute favorite part of her review. She did a deep dive into the default design aesthetics. Basically what the model builds when you don't give it strict brand guidelines.
Right, its natural tendency.
Exactly. She noted that Claude, specifically Fable and Sonnet, defaults to an aesthetic she hilariously called editorial slop.
Editorial slop, that's highly descriptive.
It's perfect, right? She described it as this very specific, instantly recognizable AI aesthetic. Beige backgrounds, burnt orange accent colors, excessive white space, and italic serif fonts.
Oh, I know exactly what you're talking about. It looks like a hipster lifestyle magazine from 2014.
Yes, it's clean, sure, but it's incredibly generic and overused. If you see it, you instantly know an AI generated it. Sol, on the other hand, defaults to highly unique, semantic, and highly functional user interfaces, but Sol has its own bizarre, distinct quirk.
Okay, what is it?
Claire noticed that across multiple prototypes, Sol is absolutely obsessed with the color forest green.
Forest green.
Yes. She dubbed its design style woodland elegance.
Woodland elegance. It sounds like a line of expensive outdoor furniture.
It really does. But, the structural functionality beneath that forest green paint job is what won her over. She gave a brilliant practical example of a gamified homework tracker app she had Sol build for her kids.
Oh, that's a fantastic use case. It really grounds this abstract technology in a highly relatable problem.
Right. She said her kids are coin-operated, so she needed a custom application to bribe them with specific rewards for doing math and piano practice.
Smart parenting.
Exactly. And she didn't want to hunt for a generic app on the App Store. She wanted one tailored to her exact family dynamics. So Sol built a fully functional app with a robust XP system. It had a focus mode that integrated voice functionality. Like the app literally used text-to-speech to talk to the kids, saying, "Hey, let's stop. Time is up."
That's so cool.
It had confetti animations for completed quests.
Engineering those dopamine hits.
Exactly. And it was hyper-personalized. Her oldest kid earned time with a real-life, one-on-one basketball coach, while the youngest earned Minecraft time. It even generated a secure, password-protected Parent HQ dashboard where she could manage the quests, adjust point values, and review their history.
Wow.
It built this robust, highly tailored, state-managed software essentially in one sitting.
If we step back and look at what that homework app represents, we are witnessing the total democratization of software creation.
I agree completely.
For the last decade, AI has primarily been a text generator or a coding assistant for developers.
Yeah.
We are now moving to AI as a full-stack product studio for the end consumer.
The barrier to entry is gone.
It has effectively hit zero. The fact that a parent with no formal engineering background can spend 20 minutes conversing with an AI and spin up a fully gamified, personalized, state-managed application to motivate their kids, that signals a massive shift in how we consume software.
It changes everything.
We won't buy generic apps anymore, hoping they fit our workflow. We will generate bespoke apps for our exact hyper-specific needs and discard them when we are done.
Okay, I hear that, and the bespoke aspect is undeniably incredible. The utility is there. But let me push back a bit on the aesthetics, because this is where I get slightly cynical.
Okay, let's hear it.
If every parent, every small business owner, and every mid-level manager is just logging in and having Sol generate these custom apps using its default woodland elegance forest green templates, aren't we just replacing Claude's beige editorial slop with a new flavor of OpenAI green slop?
That's a fair point.
Right. Are we just trading one generic, recognizable AI aesthetic for another? I mean, if 1 million people do this today, won't the entire internet just look like a pine forest by next Tuesday?
It is a very fair critique, and it highlights a fundamental reality of how these models are trained. Yes, models have latent biases in their aesthetic training data.
So they just lean towards what they know.
Exactly. They cluster around certain visual archetypes that scored highly with human raters during their human feedback training phases. For Claude's human raters, the consensus was clearly editorial minimalism.
The beige slop.
Right. For Soul's raters, it seems to be semantic, nature-toned functionalism. However, the critical difference lies in the promptability of the design.
Promptability, meaning how easy it is to tell it to change its mind.
Exactly. Claire noted that while Soul defaults heavily to green, its underlying architectural logic, the way it assigns semantic meaning to visual hierarchy, the way it uses spacing and padding, the way it structures the DOM, is fundamentally more sound than Claude's.
Oh, I see. So the foundation is better.
Yes. You can easily prompt away the green color palette with a single sentence like, "Make this neon cyberpunk." It will instantly swap the CSS variables.
Oh, that's easy.
But it is incredibly difficult to prompt away a fundamentally confusing, illogical layout. So yes, we might see a lot of green initially if people are lazy with their prompts, but the structural bones of the application's Soul builds are vastly superior to the slop of previous generations.
I say I can accept that. The foundation is solid, even if the default paint job is repetitive. Just tell the scrappy hacker to use a different color take.
Exactly.
But Soul isn't just generating static UI elements or simple 2D web games. The sources show it breaking into entirely new, highly dynamic mediums. It is moving way beyond text and code. Let's look at the multimodal beast.
The beast, I like that.
You're talking procedural cinematic worlds and automated browser takeovers.
This is the frontier.
Mhm.
This is where the capabilities start to feel truly paradigm shifting.
Absolutely. Let's start with the Interstellar demo from the World of AI review. The reviewer used Sol Ultra to generate an entire cinematic experience. And I want to be very clear here for anyone listening. This wasn't an AI video generator like Sora, creating a pixelated MP4 file.
Right, not at all.
This was generated entirely in code inside a single 3.js file. In exactly 14 minutes of processing time, the model procedurally generated a space-themed cinematic sequence with absolutely zero external assets.
Meaning, it didn't pull a JPEG of a star field from Google Images and pan across it. It mathematically plotted and rendered the visual of every star using geometry and shaders.
Yes, but it wasn't just visuals. That single file contained a procedurally generated electronic soundtrack that swelled in intensity with the visuals.
Wow.
It contained synthesized text-to-speech dialogue that matched the narrative pacing, and it featured dynamic camera work that panned, zoomed, and tracked through the procedurally generated 3D environment.
All in one file.
All of it. The graphics, the music, the dialogue, the camera logic, generated simultaneously in a single block of code in 14 minutes.
What we have to understand here is a concept called multimodal coherence.
What does that mean exactly?
Well, in older piecemeal AI workflows, if you wanted to build an application with sound and visuals, you had to use different models. The coding model would write the script for the visual. Then you'd have to separately prompt an audio model to generate a soundtrack.
Sounds tedious.
It was. Then you'd have to use a text-to-speech model for the dialogue. And then you, the human, would have to manually write the logic to try and synchronize them all perfectly. The models didn't understand the relationship between the modalities.
They were just working in silos.
Exactly. What this Interstellar demo proves is that Sol Ultra possesses a unified, latent understanding of different modalities and how they intersect in time.
It understands how they fit together.
Yes.
But
It isn't just generating code. It is simultaneously acting as the spatial cinematographer, the musical composer, and the narrative screenwriter.
That is just wild to think about.
It understands inherently that when the virtual camera pushes in on a dramatic visual element, the musical score needs to swell, and it writes the mathematical code to execute both flawlessly in sync. That level of orchestration, derived entirely from text prediction, is staggering.
It really is staggering. And importantly, it translates to highly practical media work, too. I mean, we aren't just making space demos.
Right. There are real-world applications.
Claire from How AI brought this down to earth with a video editing use case. As a product manager, she has to do a lot of social media clipping, which she noted is an incredibly tedious manual process.
Oh, it takes forever.
It really does. So she had a massive raw video recording of a talk she gave at an event for the code editor Cursor. She dropped that raw, unedited video file straight into Codex, which is OpenAI's coding and execution environment, and simply typed out a request.
Okay, what did she ask for?
She asked Sol to cut the video into 5 distinct social media hype clips. She gave it heuristic instructions, format them horizontally, pull from the most engaging parts of the talk, and make the cuts faster and tighter than the original presentation.
So she essentially gave it creative direction, not specific time codes.
Exactly.
And how did it execute?
Flawlessly. It processed the video, identified the most engaging sound bites based on the transcript and audio delivery, made the precise cuts, applied the formatting, and handed her back 5 sharp, punchy clips that she immediately dropped into CapCut to add background music and post.
It bypassed hours of manual scrubbing on a Premiere Pro timeline.
Yes, it is acting as a highly capable, autonomous junior video editor.
That is incredibly useful.
Which brings me to the ultimate power user feature, and honestly the one that broke my brain a little bit. Claire detailed her use of browser automation via the @Chrome tag inside the Codex environment.
Agentic web browsing. Giving the AI the mouse and keyboard, this is incredibly powerful and highly unpredictable territory.
Very unpredictable. So Claire was overwhelmed with direct messages on LinkedIn. A relatable problem, right?
Oh, definitely.
But instead of answering them, she instructed Saul to take total control of her live Google Chrome browser. She gave it a very specific and somewhat ruthless set of instructions.
Ruthless how?
She told Saul to navigate to her LinkedIn tab, read her unread messages, and automatically reply to them, thanking people for their support. But, and here's the kicker, she instructed the AI to only engage if the sender was an executive at a Tier 1 technology company.
An agentic screening filter.
Yes. She literally typed, "Keep the bar very high. I don't want to engage with random sets of connections."
Wow.
Saul took control of her browser, navigated the complex, constantly changing LinkedIn interface, evaluated the employment history of every single person who messaged her against her abstract Tier 1 executive criteria, and successfully burned through 500 messages, replying appropriately to the executives and completely ignoring the rest.
You know, on a purely technical level, this is a triumph of computer vision and dynamic reasoning.
How?
Well, the model has to visually understand the document object model of the web page. Interpret the layout, find the message icon, click it, read the text, navigate to the user's profile, apply a highly subjective criteria like what exactly constitutes a Tier 1 company,
Right.
and then execute a contextual response.
Right. All on its own.
500 times in a row without breaking. But on a social level, this fundamentally alters human interaction.
And that's exactly what I want to ask you about, because I look at this and I don't know how to feel.
It's unsettling.
It is. Is delegating 500 LinkedIn replies to an AI based on a strict Tier 1 executive filter the ultimate productivity hack for a busy professional? Or is this a bizarre, slightly terrifying step toward a world where my AI is just talking to your AI on LinkedIn and neither of us actually knows what we're saying to each other? Are we just creating a simulation of networking?
It's undeniably both. It is a massive productivity hack. I mean, if Claire values her time at $200 an hour, spending 5 hours sorting through generic LinkedIn messages is a terrible misallocation of her resources.
That's true.
The AI acts as a necessary shield against the overwhelming spammy noise of the modern digital world. However, your fear of AI talking to AI is not a hypothetical scenario for 5 years from now. It is the immediate reality.
It's happening now.
Think about the other side of that equation. If her AI is filtering her inbox for executives, it's only a matter of time before an ambitious sales rep uses an AI to specifically craft messages designed to trick or bypass those exact agentic filters.
Like SEO, but for human connection.
Exactly. We are entering an era of agentic social engineering.
Agentic social engineering.
Wow, the volume of digital communication is going to skyrocket because the cost of sending highly personalized messages is now zero. Consequently, the assumed authenticity of any digital communication is going to plummet.
That is a wild reality to process. An arms race of networking bots trying to outsmart gatekeeping bots.
That's exactly what it is.
But as incredible as these capabilities are, from composing symphonies in procedurally generated space to ruthlessly gatekeeping our inboxes, the sources make it very clear that GPT 5.6 is not flawless.
Oh, not at all.
It is not magic. It has some distinct, jarring blind spots. So let's look at the Achilles heel, 3D geometry and agentic slop.
It is always important to ground ourselves because these are statistical models, not omnipotent beings. They have hard edges where the illusion of intelligence just completely breaks down.
Precisely. Now, before we hit the functional weaknesses, I do want to briefly cover the safety protocols because OpenAI heavily emphasized this in their massive release notes.
Right. Safety is a huge focus for them.
They implemented layered safeguards, real-time checks, and a new reasoning monitor that assesses potential harm in context before generating an output. They specifically and rigorously stress-tested Saul for dual-use capabilities in both cybersecurity and biology.
Meaning they gave the model to red team hackers and scientists to see if it could be tricked into creating a novel bioweapon or launching a devastating autonomous cyber attack on infrastructure.
Right. And OpenAI stated that while the model is highly capable in assisting experts in these domains, it did not cross their critical threshold for autonomous danger, so it won't hack the Pentagon on its own.
That's good to hear.
Definitely. But moving from global safety to everyday capability limits, the World of AI reviewer pointed out a glaring graphical weakness. While Sol is incredible at 2D interfaces and standard web apps, complex 3D generation is still a massive struggle across all frontier models, and Sol is no exception.
What specific graphical issues was it having in 3D generation?
Despite its clean, beautiful code in 2D, when asked to generate complex 3D scenes in 3.js, the models consistently miss crucial geometric details. The reviewer noted they completely fail at generating proper mathematical reflections.
Okay, reflections are tough.
Right. They mess up object instancing, too. For example, if you ask it to render a forest, it will often render trees that clip through each other physically.
Oh, that looks terrible.
Yeah, it ruins the illusion. And they completely fail at accurate landmark geometry. Like, if you prompt it to render a realistic 3D model of the Eiffel Tower from scratch using only code, it will likely output a melting, asymmetrical pile of intersecting triangles.
This actually makes perfect sense when you think about the architecture.
Really? Why is that?
Well, 3D geometry requires a fundamental physics-based understanding of spatial relationships, light transport, ray tracing, and mathematical perspective.
Okay.
That kind of deterministic math is very difficult to derive purely from next token text prediction. A large language model understands the concept of the word reflection semantically. It knows water reflects light.
Right.
But calculating the precise vector math of a ray of light bouncing off a curved surface in real-time code is a different domain entirely. It is a hard limitation of relying solely on language to describe physics.
That explanation actually makes me feel a little better. And it reminds you that it's not magic, it's just statistical math.
Exactly.
But the second weakness is much more jarring, and it brings us back to Claire from How I AI.
Okay, what does she find?
We talked earlier about how great Sol is at crisp, direct business writing. It writes fantastic, highly structured PRDs. But she ran an agentic voice evaluation, basically testing how well the model role plays as a personal assistant in casual, everyday text conversation.
And how did Sol fare when asked to be casual?
It was an absolute disaster.
Huh?
She called it the worst. While Claude Sonnet 5 actually sounded somewhat human and restrained, Sol was incredibly, painfully cringeworthy.
Cringeworthy how?
She specifically called out its bizarre overuse of M-dashes and what she termed slop talk. For example, she asked it a simple, everyday question about moving a calendar meeting because a routine code deployment was failing.
A very standard workplace message.
Exactly. Sol replied with this dramatic, overly enthusiastic flair, ending the message with the phrase, "This deploy is a bug, not a referendum."
A bug, not a referendum. Wow, that is intense for a calendar update.
She said it was unbearable. "Please do not do this to me," were her exact words in the review. And this is what I don't understand. Why is it that this flagship model can write a flawless, highly complex executive summary, restructuring an entire corporate roadmap, but it fails so miserably at simulating a normal, boring human text message?
What's fascinating here is that we are looking at the AI equivalent of the uncanny valley, but applied to text rather than visual.
Oh, that's an interesting way to put it.
And it all comes down to the underlying training process, specifically a phase called RLHF reinforcement, learning from human feedback.
How does human feedback cause the AI to sound like a weirdo?
Well, during the RLHF phase, human raters are essentially training the model on how to behave. They reward the model for being a helpful, harmless assistant.
Okay, so they want it to be nice.
Right. They give high scores to outputs that are polite, enthusiastic, thorough, and highly articulate. Over millions of iterations, the model learns that to get a high score, it needs to perform helpfulness as loudly and explicitly as possible.
I see where this is going.
So when you ask it to be casual, it doesn't actually know how to be casual. It just applies a heavy synthetic filter of what its statistical weights think casual helpfulness looks like based on its training.
It tries entirely too hard.
Exactly. It uses dramatic pauses, hence the overuse of M-dashes, and it reaches for overly profound metaphors, like comparing a routine software bug to a political referendum, because its training tells it that using advanced vocabulary demonstrates high-level engagement.
Okay, that makes so much sense. It's exactly like a 50-year-old corporate lawyer trying to write dialogue for a teenager on a CW drama.
Yes.
It's trying so hard to sound relatable, cool, and profound that it completely circles back to being robotic and deeply alienating. It lacks all subtlety.
That is the perfect analogy. It completely lacks the human intuition for restraint. Humans know that a simple, "Ah, moving the meeting to 3 p.m. is the most polite, efficient response.
Right.
But the AI's training tells it that a 3-paragraph essay on the philosophical nature of failure is better because it uses more tokens and demonstrates more effort.
Well, hopefully they iron out the CW teenager dialogue in the GPT-6 training run.
We can only hope.
But for now, we have covered an immense amount of ground today. Let's pull this all together. For you listening, whether you are architecting complex, multi-agent coding workflows, managing a messy product pipeline, or just trying to survive an inbox of 500 unread, spammy LinkedIn messages, the arrival of GPT 5.6 Sol represents a massive, undeniable shift.
It really does.
We are moving away from the era of theoretical, pedantic intelligence like the alien engineers who refuse to ship and entering an era of scrappy, practical, duct tape effectiveness.
Yes, exactly.
And at half the cost of its main competitor, with those game-changing caching discounts, it is a massive win for everyday knowledge work, even if it does try to paint your entire interface forest green and speak to you in dramatic metaphors.
The democratization of complex workflow orchestration is officially here. It is no longer just for enterprise developers.
It truly is. But before we sign off, I want to leave you, the listener, with something to chew on. Based on everything we've unpacked today, the economics, the parallel reasoning, the browser automation, what is the one provocative thought, the unseen implication of all this that people aren't talking about yet?
It comes back to the intersection of that ultra mode and the LinkedIn browser automation.
Okay.
Think about this logically. If GPT 5.6's ultra mode defaults to coordinating 4 sub-agents to complete your tasks in parallel, and you are simultaneously letting it loose on live web browsers to interact with other companies, screen vendors, and reply to messages.
Yeah.
What happens when your 4-agent cluster encounters another company's multi-agent cluster on a B2B platform?
Oh, wow.
We might be weeks away from a shadow B2B economy where millions of microtransactions, vendor negotiations, and product procurement decisions are happening entirely between interacting AI swarms.
Just bots talking to bot.
Exactly. They will be negotiating pricing and features in milliseconds at speeds and volumes humans can't even monitor, let alone control. If your AI is automatically rejecting software vendors on LinkedIn and their AI is dynamically adjusting its pitch in real time to bypass your AI's semantic filters,
That's terrifying.
are we ready to realize that humans might no longer be the operators of business, but merely the bottlenecks in our own organizations?
That is a staggering thought, a shadow economy of swarms. We started this deep dive talking about how fast things are moving and how hard it is to keep up. It seems like with GPT 5.6, we finally built the ultimate engine to help us do our work faster, only to realize that the engine might just start doing the work and the negotiating without us entirely. Thank you for joining us on this deep dive. Keep exploring the boundaries of your own workflows, maybe double check who your LinkedIn is actually talking to, and we'll see you next time.